Hi everyone, my name is Cameron Kashani and I may have developed shape embeddings for AI and natural language processing. Space dimensions are two-way, and time dimensions currently appear to be one-way. On the left is an example 2D model. The number of space dimensions seem to be the number of connected lines divided by 2. So looking at node 5, there are seemingly 4 connections implying 2 dimensions. On the right is an image indicating the information flow between nodes, between time increments, and that kind of looks like a neural network. Nodes may store numbers. During each calculation, edges may store numbers. It's almost as if the edges are enabling information communication between the nodes. You'll notice that in the diagram on the right, the information is shown as being two-way. The information is shown as being two-way because information may be transferred kind of between the nodes. A two-dimensional model could possibly represent, for example, the diffusion of a substance in water. So shapes are kind of like graph structures in space, where each node may be storing information on coordinates. I think space dimensions are two-way, so I've drawn kind of like a two-way information communication between each node in this triangle. The images depict a triangle. A shape is kind of like a graph structure in space, where each node may store information on coordinates. I think space dimensions are two-way. So the image on the left depicts sort of like a possible two-way communication between each node in the triangle. So what I call shape embeddings are kind of like a fixed number of numbers to attempt to represent any shape or sequence. Possible cases of shape embeddings may be expressing meshes, text, and images to models, and possibly being able to interpret meshes, text, and images that may be generated from models. This slide is an introduction to word embeddings. The image shows a graph structure of a sample vocabulary. The nodes are representing words, and the edges show possible connected subsequent words. For example, the cat drank some milk as a possible sentence. The word embedding model may be trained so that words are connected to their surrounding contextual words. So, for example, a word may be an input and the subsequent words may be an output. To further demonstrate, here is a slide showing a possible word embedding model. Word embeddings may be expressed from weights from a layer in a neural network. There are existing word embedding packages. The word embedding for the word person in this model would be W1, W2, as shown in the image on the left. Word embeddings may be considered as weights extracted from a layer in a neural network. The orange highlighted nodes would be an example data point. So considering the word the, possible subsequent words may be person, cat, and park, and here it may be assumed that the words person, cat, and park are equally likely to possibly occur after the word the. So Existing packages currently only seemingly provide embeddings only for single words. So existing packages, when attempting to express sentences, may only be taking the mean of the word embeddings, which may not fully encode a full shape or sequence. So I may have developed embedding models to describe shapes. In this context, I may have assumed the edges to be two ways to represent information flowing to and from nodes. When training my shape embedding model, I consider a node to be an input and possible connected nodes to be an output. When training my shape embedding model for this triangle, I may be considering that there are 6 data points, as I may be assuming that information may be flowing to and from each node. The model may then sort of like represent the shape. The model may then sort of like represent the triangle. I trained a neural network model on these coordinates. So each node in this neural network model kind of represents a dimension. And as the triangle coordinates are two-dimensional, only 2 nodes within this neural network model are considered. The other nodes may receive zeros as input, as the other dimensions that are considered padding dimensions are not necessarily utilized for this triangle, which is 2D. So I consider a sentence to kind of be possibly like a shape in a space, in that each word may represent a word embedding point in a space. The image shown are word embeddings that I PCA compressed to 2D for visualization purposes. I did train the PCA model on a wider vocabulary. The sentence shown in the image is "a cat walked to the store." The image kind of shows the process that I may have considered to develop these shape embeddings. So I may have considered word embeddings from an existing package. I may then have used PCA to possibly compress the word embeddings to a fewer number of dimensions. I may then have trained a shape embedding model. I may then have considered the weights in one of the layers of the shape embedding model as possibly being the shape embeddings. One way I may have considered to determine whether the shape embeddings may have been functional is to consider similarity metrics between sentences. In this case, sentence 0 and 1 are similar, and sentences 2 and 3 are similar. The image may demonstrate that when the shape embeddings between sentences 0 and 1 and sentences 2 and 3 are compared, that the shape embeddings may indicate some similarity between sentences 0 and 1 and sentences 2 and 3, while also suggesting possible distance between the other combinations of the sentences. In my next steps, I may attempt to train a model to predict something with text as an input in the form of the shape embeddings. I may attempt to compare mesh similarity between two mesh shapes by comparing the two meshes' shape embeddings. I may attempt to recover shapes from the shape embeddings for possible model textual output and possible model mesh output. I think that maybe the viability of comparing, for example, an image embedding and a text embedding directly may not currently be optimal, outside of possibly a mixed image and text embedding dataset. I think the possibility of comparing any data structure by shape embeddings may possibly seem to be more in the direction of optimal. Thank you for listening.